Hello everyone, this is George from Greenware Services. As I have noticed, many data analysts are confused with terminologies of linear mode, linear regression, and linear programming. I would like to use this video to explain what are the differences among those terminologies. Let me explain the linear model first. A linear model means the dependent variable has linear relationship with independent variables. For example, variables x and y has a linear relationship like y equal to b0 plus b1x. So their relationship can be represented by a straight line in this graph. As a comparison, a nonlinear model indicates a dependent variable has a nonlinear relationship with independent variables. There are different functions of nonlinear models, such as polynomial, power, exponential, and so on. Let me give a simple example of quadratic functions, like y equal to b0 plus b1x plus b2x squared. So this quadratic function can be represented by a curve in this graph. It's not a straight line. That's why it's a nonlinear model. Now let's move to linear regressions. Linear regression uses linear equations to estimate the coefficient of a model. It focuses on the coefficients, not the variables. For example, a simple model y equal to b0 plus b1x. In these models, x and y are variables. b0 and b1 are coefficients. So we can say the coefficient b0 and b1 has linear relationship. That's why this model can be estimated by a linear regressions. Since linear regression focuses on the coefficients, not the variables. So for some nonlinear models, if their coefficients have linear relationship, the model can still be estimated by linear regressions. For example, in this exponential models, variable x and y has exponential relationship. Their coefficient b0 and b1 still have a linear relationship. So this model can still be estimated by linear regressions. So to make it clearer, I give an example of model that cannot be estimated by linear regressions. In this model, x and y has nonlinear relationship and have like power functions. And this model has three coefficients, b0, b1, and b2. And b1 and b2 has nonlinear relationship. So this model cannot be estimated by linear regression. So we have to use nonlinear regression to estimate their coefficient. Some people may have heard about linear programming. Linear programming is a type of optimization technique. It usually has linear objective functions, such as here, z equal to c1 x1 plus c2 x2. x1 and x2 are the two decision variables. c1 and c2 are their weights. They could be a factory's production or a profit. We usually need to maximize or minimize Z. By this kind of maximization or minimization are under a number of constraints. Those constraints are usually linear functions, such as we list an example here. If we present this kind of functions in the graph, it will look like this. Here we have decision variable x1 and x2. And here we have 4 blue lines. These 4 blue lines represent 4 linear constraints, and the blue areas surrounded by the blue lines represent feasible solutions. We can search these blue areas to find the best solutions. Actually, the best solution is one of the vertices. That's a linear programming. So in summary, linear model and nonlinear model, we distinguish them based on the relationship between variables. Linear regression and nonlinear regression, they are determined by the relationship of coefficients, not the variables. Linear programming is a kind of optimization algorithm. It has a number of linear constraints within the techniques. Thank you for watching the videos. I hope you have a better understanding about these terminologies now. It will be my great pleasure if this video can help you do better analytic job.